Hey guys, this is 5-7, the binomial theorem. Today we're going to talk about how you use Pascal's triangle and how this applies to expanding binomials. So you can see here, you can use patterns of coefficients and patterns of exponents in order to expand terms like a plus b all raised to the n. So you know how to do like to the 0 power, to the first power, to the second power. But today we're going to look at what is the most efficient way, instead of foiling, to write out these binomials in standard form. So the way that we're going to do this is start out by looking at Pascal's triangle. You'll notice here that it's coefficients only, okay? So this is just talking about the number part that goes in front of each term that you're expanding. This was created by a famous mathematician. His name was Blaise Pascal, and he was the one who came up with this and got credited for it. You'll notice that there are ones at the beginning and at the end of each row when you expand, so that's something to definitely keep in mind. And it also says each of the other numbers in the row is the sum of the two numbers above it. Now later on I'm going to break this down, but you might want to pause the video here and you might want to jot these down. We're definitely going to go all the way. Typically on non-calc we'll probably have you set it up and go through like the 6th power, but it's not uncommon for you all to see higher powers. So on this next slide, I'm going to analyze how Pascal came up with these triangle, that pattern that you see there on that previous slide. So I'm going to do this based off of the scenario of having children. So one day I plan on having children, and I'm going to relate this to how the numbers came up in Pascal's triangle. So you can see my first option would be 0. If I want to have 0 children, that means I only have one option. I would have no children. There's only one outcome, having no children. So that's where that first term comes from. The second row, you'll notice, is a power of 1. Okay. So let's relate this to the scenario that I was talking about earlier. We're going to let A represent girls, and obviously B will represent boys. So if I have one child, I can either have one girl or I will have one boy. So that's where those coefficients 1 and 1 come from. I could have one girl or I could have one boy. Now, when I have 2 children, I have A plus B to the 2nd power. Well, I'm going to come down here and write this out for you. I could have 2 girls. I could have a girl and then a boy. Or could I have a boy and a girl? Yeah, those are the same situations. Or I could have 2 boys. So, as you can see, this is one scenario, this is 2 scenarios, and this is one scenario. So this relates directly to our coefficients. For the third row, if I want to have 3 children, this is where it gets a little complicated. If I want to have 3 children, I'm going to break this down for you down here at the bottom. I could have 3 girls. I could have 2 girls and a boy. And again, I can have that in any order. So I could have girl, girl, boy, girl, boy, girl, or I could have boy, girl, girl. Same thing, I could have 2 boys and a girl. And again, any order, that doesn't matter. And then I could have all boys. So as you see here, this is one option. This gives me 3 options. This one also gives me 3 options, and this last one gives me 1. So again, I get my coefficients. I'm not going to do 4. That's too much. That's just way too many options. But you should be able to start getting the picture. Now, as I mentioned on the first slide that introduced Pascal's triangle, there is a shortcut to creating the coefficients if you can't memorize them, but I strongly suggest that you do memorize them. You'll notice here, it's broken down for you how they are come up. So in order to get the next row, you take the two terms from the previous row and add them together. So I'm looking at this right over here. If I have 1 plus 4, that gives me 5. 4 and 6 give me 10. 6 and 4 give me 10. 4 and 1 give me 5. And then you'll notice here, this is just the middle terms, okay? That's just the middle coefficients because you always know that you're going to have those ones on the outside. So in order to come up with Pascal's triangle, there is a shortcut. You just take the sum of the previous row, and that'll give you your next two terms. Now, here is the meat and potatoes of today's lesson. You need to reference these and write these down. These are the steps that we use when dealing with Pascal's triangle. So the first thing that we're going to do is we write down the coefficients, okay? I'm going to make a note here. Listen to me say this. You're going to write these terms vertically, okay? You're going to write them vertically, and you'll see why I do that on the next slide. After that, you're going to write down the A term, so your first term, with the exponents from greatest to lowest, okay, or smallest, whatever you want to say there. And we definitely want to make a note here, we're going to end all the way down through 0. Our next step is to take the B term, the second term, and we're going to do the opposite. We're going to start with the lowest power and go to the highest power. Again, make sure you start with 0 for your lowest power. And then my last step, we're just going to perform the math and rewrite as a polynomial operation. So on problem number 1, there is the binomial theorem written at the top, but this will make a lot more sense when I go through the problem. So what is the expansion of a plus b to the 6th power and use Pascal's triangle? We don't want to sit here and FOIL all of these out. That would be ridiculous. So this is why we use Pascal's triangle. We're going to be efficient.
If an upstairs custodian could please dial house phone 1101, please.
Nothing like announcements right in the middle of my lesson. Am I right? I think I'm right. So here we go. We are going to start with our coefficients. So for row 6, I'm going to have 1, 6, 15, 20, 15, 6, and 1. So here I go. 1, 6, 15, 20, 15, 6, and 1. Again, I'm writing them vertically. You're gonna see why in just a second. My next step, I'm gonna start with my first term here, and I notice that it's A. Okay, we're connecting the theorem to what we're actually doing here. So I'm gonna have A to the 6th power. I start with the greatest and I work my way down. Oh, why did I write B? Okay. Now, I'm going to take my B term, my second term, and you'll notice I'm going to take the sign with it too, and I'm going to start at 0 and then work my way up. So now what I'm going to do is I'm going to evaluate every single row here. And when I do that, I'll write my final answer as a polynomial in standard form. It'll work out really nicely. So here we go. I have 1. I don't have any other numbers in here, so I can just go ahead and carry that 1 over. I know I'm going to have a to the 6th because that's already simplified. And then what's b to the 0 power? Anything to the 0 power is 1. So that's why I'm left with just a to the 6th on that right-hand side. My next term, I have 6, a to the 5th, and then b to the 1st power. I don't have to put that 1 there, but if I want to, I can. So here we go. We're going to finish this out. And the reason I'm carrying these coefficients over is because I don't have any other number attached with that a and b that I have to necessarily take care of. We're going to do some examples, though, when we do have a number in there, and you'll see how that works. So on this last one, you notice 1 times a to the 0 times b to the 6th. That is just b to the 6th. Now, this is the cool part. You'll notice that this is automatically in standard form. So, it's easy enough to transfer this over as a polynomial in standard form. I'm going to be efficient, and I'm just going to put plus signs because everything was positive. Okay, so if you wanted to write this out, you would say a to the 6th plus 6a to the 5th times b plus 15a to the 4th b squared plus all the way out to our last term, which is b to the 6th. Now I know what you're thinking. Money, do I have to write that out? I'm going to say yes, okay? If you don't, and you don't put those plus signs on the back, then I know I get to take off because you missed that writing it as a polynomial. Okay. Like I said, this is just to get your feet wet. This is just to expose you to the concept. And now we're going to do some with some actual numbers in there. Okay. So, like I said, baby steps. We're taking this one step at a time. What is the expansion of 3x minus 2 quantity to the 5th power? Use the binomial theorem. So, again, it says, think, what are you going to start with? You're going to start with the 5th row. The 5th row with my powers would be 1, 5, 10, 10, 5, 1. So, I'm going to write this here.